This video is about functionalities of online tool WooMocha, developed under the project Kava, financed by Federal Foreign Office of Germany. The team of researchers from Germany and Central Asia worked together to design and develop this tool that explores water use efficiency in the RLC basin. This video presents the exercise for users of the web online tool WooMocha with the goal to enable users for practical use of indicators with statistical input and thus to make them familiar with the user polygon toolbox for their own work. An irrigation efficiency index of 1 indicates that all water which was fed into the system actually have reached the plants. Values below 1 mean that less of water intake reached the plants, thus water losses have occurred. Values above 1 means that also other water sources have reached the plants, for example from groundwater or rainfall. This index is defined as ratio between water consumed and water input in a certain zone, such as administrative boundaries. Water consumed by crop cultivation is measured in actual evapotranspiration, which is water released to the atmosphere by evaporation and transpiration. Different sources such as irrigation water, groundwater, and precipitation are included in this value. Actual evapotranspiration is based on remote sensing and climatic data. Open WooMocha online tool using web link woomocha.geo.uni-hale.de. In the selectors list, select Irrigation Efficiency Index. Choose district as aggregation level. Base maps can be switched on or off. From the year slider, select any year of your interest, for example 2008 in this case. Click on various districts to see the irrigation efficiency variations for various years. Different districts and years with higher or lower irrigation efficiency can be identified. We could also select a particular district using area filter. For example, in this exercise, write Kata Kurgan district located in Samarkand. The boundaries of the district would be highlighted. From the line graph of irrigation efficiency, we could identify dry years, for example 2000, 2001, 2008, 2011 and 2014 by high irrigation efficiency values. The result in this line graph can be transferred to user polygon toolbox for further user specific analysis. Notice that the selected district is also visible in the user polygon toolbox. Press the button Calculate Irrigation Efficiency. A window would open for putting water intake data in million cubic meter. There are 3 options for this data input, including yearly data, monthly data, or by decade. The data is only possible for summer months. There are 2 ways to enter data, either by typing manually in this form or import data saved in a separate Excel file. To know about the data input pattern in the Excel file, template can be downloaded. For example, we download template for by decade. Here M4_1 represents first 10 days of April, M4_2 represents second 10 days of April, and M4_3 represents last 10 days of April, and so on, so forth. For this exercise, we have already prepared data input file for district Katakurgan, so we will use the data import function. So data is imported to WooMocha, and in the next step, press button Calculate Irrigation Efficiency. WooMocha would start estimating irrigation efficiency. Be patient as it would take some time. It also depends on the amount of data input. The calculated results can also be downloaded for further analysis. Press Download Polygon button. A window would pop up with various options. The data could be downloaded in Excel file format or shapefile, etc. For this exercise, we would select Excel file format. In the select year option, select all, and in indicator list, select irrigation efficiency index. Press download button and Excel file will be downloaded. This downloaded Excel file would have various input variables and output variables. The input variables include ETF actual evapotranspiration and WF water intake, whereas the output variable is VIR, that is also called as irrigation efficiency. The data in this Excel file can be represented in various graphs. For example, the current graph is between years on x-axis and irrigation efficiency on y-axis. If irrigation efficiency value of 1 is benchmark, then years with lower and higher irrigation efficiency values can be seen very easily. The trend in irrigation efficiency values is generally increasing from year 2000 to 2018. In this second graph, input and output variable values are plotted for category from 2000 to 2018. It is clearly evident that years with low water intake showed higher irrigation efficiency, whereas the years with high water intake to system result in decreased irrigation efficiency values. It is to be noted that ET values are not changing very drastically, so increased water intake into system is not translated into higher ET values. Rather, it would go to other irrigation system losses. This last graph digs further deep into patterns of irrigation efficiency. It is clear that higher values of irrigation efficiency are observed for months from April to June, although with high uncertainties. Comparatively lower irrigation efficiency values are evident for rest of the months in the cropping season.